Today I'm going to be doing a quick video going over the differences between nervous, skeletal muscle, and cardiac muscle action potentials. Before we start talking about the action potentials themselves, I think it's important to talk about the major players. We've got the channels that are open at resting membrane potential. Those are the major player here is the leaky potassium channel in all of these different tissue types, but there are also other channels that are open at rest. Then we have our stimulus channels. Most often those are going to be ligand-gated channels or mechanically gated channels in the case of nervous tissue. In the case of skeletal muscle, you're going to have your acetylcholine receptors. You'll have some of that in nervous tissue as well. And in cardiac muscle, that is going to be gap junctions and other things like that that are going to carry the charge to the tissue, okay? And then we have our voltage-gated sodium channels, our voltage-gated potassium channels, and our voltage-gated calcium channels. Now I've drawn over here a little diagram showing relative concentrations of ions. Sodium is much higher concentrated outside the cell than in. Potassium is the opposite. Calcium is higher outside than in, and chloride is higher outside than in. We're not going to talk a lot about chloride today because it doesn't have a lot of bearing on this, what we're talking about, but that will be important later. Now, if the ion is more highly concentrated outside, then it's going to want to go into the cell when those channels are open, and vice versa. If it's more highly concentrated inside, it's going to want to go out. And we can kind of use that to rationalize why we're seeing what we see here, okay? So let's go ahead and start with the nervous action potential. So these channels that are open at rest, they're going to be open pretty much the whole time. So this blue line follows the entire action potential. That's going to be the same for all of them. Now, resting membrane potential in nervous tissue is typically going to be around -70. Now that can vary, but that's going to be a typical value. The channels open at rest in skeletal muscle, on the other hand, are going to cause resting membrane potential of about -90, much closer to the equilibrium potential of potassium. And the channels that are open at rest in cardiac muscle are actually going to cause about -85 millivolts resting membrane potential. Okay, so when the stimulus channels are opened in nervous tissue, that's where we get this rise until we get to threshold. Now, at threshold, both sodium and potassium channels will be activated in nervous tissue, skeletal muscle, and in cardiac muscle. Actually, in cardiac muscle, these L-type calcium channels are also going to be activated by that depolarization that happens there. These sodium channels are very, very quick to react, okay? So we get this upshoot, this very, very quick upshoot because the sodium channels are open, the potassium and the calcium channels are not yet open. And we see that in all three tissue types. We get this upshoot. It's shooting up towards +65 millivolts. It doesn't get that high, but that is because the sodium channels are opening. That's why it shoots up there. Then the sodium channels in all three are going to be inactivated. They have an inactivation gate that closes after about 1 millisecond, and that stops the upshoot, okay, in all three. At about the same time, in all three, we get the voltage-gated potassium channels are finally responding. Okay, they were activated down here, but they're finally responding after about 1 millisecond opening up. So we get the cell starting to repolarize, okay, in all three tissue types. In nerve and skeletal muscle, that's about it, right? It repolarizes, and we get this hyperpolarization in nervous tissue because resting membrane potential is above potassium equilibrium potential. We don't see that quite as much in skeletal muscle because it's not above the potassium resting membrane potential. It's right at it, the resting membrane potential. So we don't see that same effect in skeletal muscle quite as much. But what I really wanted to talk about was this right here. Okay, why do we get this plateau? And the reason we see this plateau is because of these voltage-gated calcium channels, the L-type channels, are unique to cardiac muscle. And they are very, very slow to open, even slower to open than these potassium channels. Okay, so they take a minute to open, which is why we get this slight repolarization and then the plateau. Calcium wants to go in, potassium wants to go out. So we have positive charge coming in, positive charge going out, and it actually ends up bouncing out. That's why you have a plateau at all. Those calcium channels, though, are going to be inactivated after 100 to 200 milliseconds or so, and that's when we again see our repolarization with those potassium channels, bringing it back down to resting membrane potential. Those are the differences for these three tissue types. I'm going to be doing another video comparing cardiac muscle to the sinoatrial node, which is important to understand. Thank you for watching this video. Please subscribe to my channel and like these videos. You guys are awesome. Bye.